M&Ms are a brand of candy produced by Mars Incorporated. They were named after the founder of the Mars Company, Forrest Mars Sr. and Bruce Murray of Hershey's. As you all know, M&Ms are colorful button-shaped chocolate candies that contain a lowercase m printed on one side. Milk chocolate M&Ms were the first of its kind to be manufactured. In our experiment, we used red milk chocolate M&Ms. Red M&Ms contain only one main synthetic dye, red 40. We are interested to find out how many milligrams of red 40 is in 7 red M&Ms, which is one packet, because it is a mystery to the world. Red 40 is a man-made dye that is widely used in today's food industry. The scientific name of red 40 is... Some research suggests that red 40 can lead to cancer and other harmful side effects. By finding the amount of red 40 in 7 M&Ms, some may ponder whether eating such a candy is worth the potential risk. This is the chemical structure of red 40. Circle is the acyl bond found in all food colorants. The independent variable is the M&M color. We chose red M&Ms. The dependent variable is the amount of red 40 in milligrams in the M&M solution. The control is the milliliters of distilled water used to dissolve the M&Ms. We use 100 milliliters. If we dissolve 7 red M&Ms into a set amount of distilled water, then we will find that 7 M&Ms has approximately 11.77 milligrams of red 40 in it, because we know less than 1% of one packet of M&Ms is composed of corn syrup, dextrin, red 40, and gum syrup. We gave each of these an estimated percentile based on the order printed on the package. We gave corn syrup 0.40%, dextrin 0.30%, red 40 0.20%, and gum syrup 0.10%. Since 7 M&Ms is roughly 5,880 milligrams, 0.20% is about 11.77 milligrams.
Procedure. First, separate all the red M&Ms from the rest of the pack, about 7. Soak in 100 milliliters of distilled water until the candy coating is completely white, then take what's left of the M&Ms out. Use a Bouchon funnel to filter out any extra ingredients, maybe 3 to 4 times. Fill 6 cuvettes with the different concentrations, and 1 with distilled water and 1 with the M&M solution. Calibrate distilled water in the colorimeter and collect and record all absorbencies and concentrations. Then use interpolate to find the concentrations of the M&M solution. Data collection. This is data table number 1, concentrations and absorbences. During our experiment, we recorded quantitative and qualitative data. We found the concentrations and absorbance of each cuvette and took the qualitative observations. Here is our graph of concentrations and absorbance. As the concentration of the solution increased, the absorbance of the solution also increased. This is the directly proportional linear relationship. The equation of this line is absorbance equals 25.08 inverse of milliliters minus 0.01359. The calculations we did is 0.023 milligrams over milliliters times 94 milliliters equals 2.16 milligrams. Based on the absorbance of the M&M solution, we are able to find its concentration due to its directly proportional relationship between concentration and absorbance. Since we knew the concentration of the solution, we are able to multiply the concentration of milligrams/milliliters to the total amount of the M&M solution to find the total amount of milligrams of red 40.
After completing this experiment, we found that 7 M&Ms contains approximately 2.16 milligrams of red 40. We originally hypothesized that 7 M&Ms would have about 11.77 milligrams of red 40 based on the order of ingredients. We are only 9.6 milligrams off the actual amount. There are many factors that could have impacted our results. For instance, we lost a small amount of M&M solution in the process of measuring, filtering, and pouring it into different utensils. This small amount is significant in determining the total amount of red 40. Therefore, the total amount of red 40 is lower than the actual amount. To guarantee this is not an issue for future experiments, we can use a set amount of distilled water to rinse out every material used to hold the solution. Therefore, every little drop of the M&M solution will be counted for. Another error we did not take into consideration was 100 milliliters of distilled water used to dissolve the M&Ms in the beginning of the experiment. Since we used 100 milliliters of distilled water in our solution, the red 40 became less concentrated. Because concentration and absorbance is a directly proportional relationship, the lower the concentration, the lower the absorbance. Thus, when we measure the absorbance of the solution, we get a lower value than what the absorbance should have been. Therefore, this impacted the concentration when using interpolate to find the matching concentration. This explains why the actual value of milligrams of red 40 is lower than expected. To ensure this is not a future problem, it is necessary to include that 100 milliliters of distilled water in the process of finding the total amount of milligrams. Thus, we would have to include it in our final calculation. Today, reactions to synthetic dyes are classified as food intolerances rather than food allergies. The amount of red 40 present in a food product is important to those with an intolerance to synthetic dyes or red 40 itself. For instance, our friend Tyler Galway has an intolerance to red 40. He cannot consume any food products containing red 40. Therefore, it is important for him to know the ingredients of the products he is consuming. In some cases, some with dye allergies can only tolerate a certain amount of dye. Labels do not display the amount of dye used in the product. Therefore, most people with dye allergies avoid the dye completely. Knowing how many milligrams of red 40 per serving is important to people who are monitoring their intake of synthetic dyes, whether they have intolerance to red 40 or want to avoid artificial additives altogether.